Hello, everyone, and welcome to Handmade Hero Show. We code a complete game live on stream. We we don't really know what we're gonna do today, um, because we we sort of finished the layout stuff that we wanted to do, and I think in terms of like moving forward on gameplay stuff, probably the next good thing to work on would be like trying to play around with with combat stuff, just so I can get a feel for like how to make that interesting, like how like essentially I kind of like the tile stuff. It worked out roughly the way that I thought it would. And so I like more or less where that's going. And I think it's good enough now that we can play with it. I don't know why. What's going on here? Oops. There we go. Um, and so I don't know, on the other hand, much about the combat. So I kind of want some way of like investigating that and figuring out like just sort of some basic ways that that can be fun. And part of that may just be like making sure that it feels good, and that's just a matter of like polish. But there's also just a question of like what exactly you do in there, right? So at least at the moment, I like the tiles, and there's a couple things too. While we're doing the gameplay stuff, we should fix the tiles so that it triggers when you land on them, just so you can see, so it looks better. Uh, and then there's also a couple other things, like we want to fix the going down too far issue, where you're allowed to like push them down really far. So there's a couple of things we'd like to do, but on the whole, I would say like kind of minor, and we can get to those at any time. Whereas like combat stuff, we just don't know, right? So I'd like to go in and try to make like punching feel good. We don't really have anything in there except for just the fact that we, proved we could animate this little glove thing. But I don't really know how this is going to feel. And furthermore, excuse me. Um, Furthermore, I don't actually know how we might want to deal with the like. You'll notice this dude just left, right? We also have that weird room thing where if you go outside of the room, it doesn't find a room volume, and we should probably fix that. Not that it will happen, because that's just a bug that those go down far enough anyway, but it's still just kind of weird. So we don't also know like what we want our enemies to do. So for example, right now that guy's just moving randomly, and you can see he just like left, right? He just walks out of the room that he's in. And I mean, it's kind of interesting to be able to have enemies that can move from room to room, but at the same time, it's like, well, that's not very interesting from the standpoint of like actually playing the game. So we probably need things that are like, okay, enemies, maybe having them seek the player will be enough to prevent that. Maybe it won't. I don't know. But we probably need some idea of like, we don't want all the enemies like leaving the rooms they're in, and because that doesn't really make for very good gameplay either. So I think, I don't know, and like I've said many times before on the stream, my understanding of how usually to proceed in game design, which I don't do, so I don't pretend to know, but my understanding is that like usually you want to sort of play with things and try out some ideas and try to follow ideas that feel good when you actually put them together, because much like with programming, you can't really know ahead of time all of the subtle issues that might be involved in what you're doing. And so if you try to like plan everything out ahead of time, it doesn't really work very well. And so, I'm going to try and follow that advice, right? Let's go ahead and take a look at that, and we'll go from there. By the way, I noticed the chat was talking about the fact that I'm not facing what I'm doing. Yes, I flipped it, and everyone freaked out. They were like, no, you have to be facing the other way. So you guys need to argue among yourselves about that, because that is not my responsibility. That was you folks not knowing what you wanted. So you're going to have to have your own little you're going to have your own little argument there. All right. So, what do we want to do here? I guess gosh, I just don't know, because like I said, this isn't really something I do. But I guess what I'd like to do is maybe have... I'd like to maybe start out by having the combat be a little bit asymmetric. So I'd like to start out by having you on squares, which you are, right? And the enemy that you're fighting just floating. So the enemy is not like on a square at all, right? The enemy will be like... The enemy will be moving continuously over the board like a hovering thing. And I feel like that would be probably the best option. That's my guess, right? That's what I want to start with. And there will be hopping enemies for sure, but I think those will be like later. So I think the first thing you encounter would be a floating enemy. And so its movement and your movement are different, because I think that's somewhat interesting. So I don't know. But I think that's what I'd like to start with. And I don't really remember to what extent we preserved. We had some test code in for something like that a long time ago, just because, we did. And if I remember correctly, there was ways of doing that, like, I don't know what that means, but we had like the familiar, and the familiar, for example, as far as I know, this thing just kind of floated around, right? Now, I don't know, we haven't tried it in a while, so I don't know, we probably need to update some of that code or whatever, but we could start with that and try to make an enemy that uses basically that path, that basically, does the same basic stuff, which we can go to like the room gen thing and just have it everywhere that we were adding monstars. We could add, world gen. We could add just the familiar and see what happens. Now, I don't actually remember... I think there is no actual, like, logic to it at the moment, right? It just kind of slaps down enemies in rooms, any dungeon room, I think. So, like, when it does add... what is it? Create dungeon. In here, it does a thing where it adds... something like this. It adds a snake... So this snake pattern. So I assume that we can just add a familiar and see if it works, right? It's just been kind of sitting in there for a long time. And I think we can do that. So if you look, the snake pattern is somewhat complicated because it actually adds a bunch of stuff. We can have sort of a more generic entity pattern thing that just plops down anything for now. So I can do, like, single enemy pattern. I don't know. Just some pattern that we're going to place in here. And what I can do is just literally ask for a random tile anywhere, and then place it down. And I think that's all I need to do. Excuse me. And again, I don't actually know. We added the familiars... It looks like we still have the code for how it worked in here when we added it. So what I'll do is I'll just kind of grab that code for now because I don't have any better idea. And we'll just go in here and make a thing that like places the head and the shadow on there. And for now it's going to be a familiar, which will not attack you. It'll just follow you around, right? So if I compile this, I should get any errors that are like, what do we need to fix to make this work the way we would expect? So first of all, this was done before we were using the construction grid, so we just move to using the construction grid to get the region. For occupying here, what you can see here is we're using this pattern here where we do place entity on traversable, right? And it's this kind of code where we just say we want to put it on this tile. So this code specifically, we can just replace here by calling calling this code, and we're going to use the head tile instead of this standing on that was the thing that used to get passed. So in theory, I believe we can just do that, and that will place the entity onto the tile that was supposedly open using the find random tile thing. And then when we do the add piece code here, we just have to make sure that we can construct a familiar using the stuff that we, basically we just need to change this stuff so that it gives the proper asset tags to add the familiar. So again, not much to really do here. We don't have to actually assign an entity position because that will get taken care of for us. So really, we're just giving it a familiar brain. We're giving it a location. We're placing it on this tile here. And then we just need to update this code. So if I look at the way that we've been doing that, in fact, I can just go down here and you can see it. So when we actually do the piece construction, you can see this is the piece here, right? You can see it. So if I grab that stuff, I don't know if we probably need to do some extra like stuff where we actually do the connections and such, right? And I don't know about shadows because kind of now I don't think we're putting those in anymore manually. So it may be that we don't really care about any of that stuff. We do have the piece move bob offset part of things, which we may want to do. Now, I don't know how we've been like doing that. Looks like you just you just added up the flags at the end, still like we used to. So in theory, that should just work. And we probably don't need like most of the rest of this stuff. Apparently, the familiar was larger than, so I don't know if it still should be or not, but it was. And then it was also just like floating directly, right? It didn't have an offset. So that may all be wrong. We don't really know. And I'm just going to try it and we'll see what happens. Oh yeah, this is supposed to be entity. And this is just the piece. So I think that's about it. The base asset in this case for the body, and it probably should be the head, right? I assume. But here that's going to come from the pattern. So the base asset, so that people can change like the look of it, right? So I suppose that just gets added like this. And so now I don't know. I suppose we should reduce the number of these. This is going to get old if I have to. I probably need a hotkey that's just like open all of the doors in this room because we're testing, because that's going to get old pretty fast, right? But so hopefully, let's take a look. We are able to add a familiar here. I don't actually see one though. Did I ever actually add it? You know what? I don't think I ever actually added it. I think I spaced. Yeah, I did. So you can see here, like, if we just wanted to add one of these to rooms generally, here's the familiar. And actually, I'm just going to call this enemy for now because we're not going to actually want it to be a familiar eventually. So I'm going to change that anyway. But we'll just do, all right, this is single enemy pattern. I don't know which of these we want, but I'm going to leave those as they are for the moment. And now we'll try again. And also I'll go in and do so there's the tile switch pattern. I'm just going to if zero that out. It's working just fine. So I'll if zero that out, and I'll also remove, we were drawing lights before, and I'm also going to turn that off because I don't have any real need to see that at the moment. So in the piece type light code there, I'm just going to turn off the little cubes that were floating wherever we had lights because we don't need to see them. They just are where they are now. So I turned off the switches. Oh, and there's the familiar. So I think now we can just go ahead and try to turn that code back on and see if we can get the familiar floating around. Which again, we don't actually care about the familiar per se. I just want to get floating working properly so that we can use it more generally. So you can see here where the brain code executes, it's looking for the head. It tries to find a location, it looks like, and I don't know what blocked is supposed to mean. I guess it's just, can it occupy the place where it is? I'm not sure what that means. Why would it be looking for that? So I don't really know. I don't really know what this first part is supposed to be doing. So there's a target P, right? And I guess just looking at this, it looks like nobody ever uses it. So I'm guessing we just cut and pasted some of this code when we wanted to keep it, but it doesn't look like anyone uses it, right? Oh, no, okay, so never mind, it is used right down here at the bottom. So this applies an acceleration to this character based on the target P. So it's got a little, like, this is a proportional derivative controller here, right? Also known as the PDC. So just a basic spring attached from the position that you are at currently to wherever it is you want to go, and it was supposed to kind of spring them along. So it does look like it's actually using it, and the question, of course, is why is this target P not actually therefore being effective? So what I might say is the blocked part of things, I'm just going to turn off for now. So I'm going to say that, well, actually, you know what? I don't even have to do that. I can just do this. So I just want to see what happens if this code is still working. It looks like it's looking for a hero to follow. And so I'm assuming that if I do that, I can go in and debug that code now to find out why it's not actually moving, right? Because you can see it's not moving. It should be locating me. It may just not be finding it. So in other words, it may like be doing this and not getting anything back. Or this isn't working anymore, right? Again, this code is ancient. We just have never used it with any of the new stuff. So let's just go in and see, because now we know that this case won't be obviated by the traversable check up here. So we take that out of the system. And we know that we're just going to use this target P and off we go. So let's just see what happens here. I'm going to quick set to debug mode and just see what's going on. And that's going to be in the brain code right here. So I'm just going to set like a... I guess I'm not going to set the breakpoint yet. I'm going to like slowly debug mode hop my hero up here into this room so that I know that this dude is there. And now I'm just going to look at that brain code here and just see what happens. I have no idea what it will do. So it does look like the target P is getting assigned here, right? And if I look at the head P and the target P, I should be able to see. I mean, they're definitely different. So you know, I don't really quite understand. Maybe did we take acceleration out of the system? It's entirely possible, I suppose. I hate the fact that when you step out of things, you can't look inside. You used to be able to do that all the time, and now you can't anymore, and it sucks. So, let me go ahead and... Oops. Let me go ahead and take a look in here at the different slots, and I'm going to see if I can determine what happens with this DDP. So this is the acceleration on here, and you can see that it's trying to push relatively hard. So it looks like the familiar code is still in play, And so that just suggests we probably just nerfed that stuff on the entity side. So meaning we probably just don't allow that stuff anymore. And so it's, using a physics thing that, we just don't do because everybody's been doing the tile-based movement. So if I look at this code, right, we're just going to take a look and see where this movement stuff would normally be happening, and is any of it happening anymore. You can see all the rendering code here, and so that all that stuff is just stuff that happens downwind of determining where the enemy actually is. And you can see that we've got like planted, which is just they're sitting in one place, hopping, which is when they're, kind of doing a jump sort of thing. And then, there's some stuff for like swiping or offset angles that like determine where things are. None of that stuff is going to do any kind of physical movement at all. So it kind of looks like it kind of looks like we just got rid of it, right? This was the code that would have done this stuff, and we just said that's not happening anymore. So I don't actually know why, because it's been so long since we've done any of that stuff. But at this point, we don't actually use any of the movement stuff. It seems like we would probably like to. So my assumption is that, at least this code, we probably want to keep inside some kind of a free, like a movement mode free kind of thing. So like movement mode floating, I would think, which is currently not used anywhere. If we had a movement mode floating, I would think it would do this thing. Like I would think it would do a check to see if there was any velocity on this thing, and then it would move it if it was. And again, I don't really know if that's what we want or not, or how we even really want to process that stuff. But I'm just going to start playing around with this until I get, until I'm satisfied with it. So I'm going to go ahead and say that up here, we're just going to turn this on for now, and we'll see what happens. Nothing good will come of it, I'm sure, but that's just what we're going to do. And then similarly, we need to set this thing to a movement mode floating, because it's not going to set itself, So in here, when something's floating around, what we would like to do is set the movement mode for the head to always be that. So the movement mode should be floating all the time. And, maybe there's some other modes that this thing can go through, but, at the moment we don't have any. So it's just going to go do its thing. I can keep running from where I am and take a look. How do I tell this to keep running? Keep running, please. There we go. So there, and that worked. So that's fine. And so it just looks like the problem with that was that, we kind of took out that movement mode. So actually all the code still worked. It just kind of had to be rewired up. And that's fine. So, that's a possibility for an enemy. Oh, and there you go. So as you can see, these folks are not subject to any actual collisions right now. Well, I mean, that's not entirely true. They are sort of subject to collisions, but they're only subject to collision volumes. So one of the things that we haven't been doing, for example, is we haven't been placing collision volumes in like walls. We just don't put movement things there. We don't put what's the word for them? We don't put traversables. So you can't hop there because there's no traversable. But one of these floating people could just go right through because there are no collision volumes there to stop them, and they only check in that move entity routine. They only check against collision volumes. So if we wanted to, we could check collision volumes, but I think the idea here was that this code was what that code was supposed to be doing, I think. I'm not really sure. So what I'm going to do is temporarily turn that on. And we'll look at it because I don't really know what it did. We'll have to look. But I suspect that's what that was for. No, it doesn't look like it. It looks like it's still able to do it. Yeah. So I'm not sure what this was supposed to do. Doesn't make a whole lot of sense either, which is why I want to turn it on to see if it somehow magically worked, because when I looked at it before, I was like, that doesn't make much sense. So yeah, this does not really make any sense to me. So probably what I would say here is that what we would rather do, I would like to get rid of this entirely. And what we would rather do is say, look, it's floating. We're going to try and find a location for it to go to. And when we do, we would probably like to say, you know, when we find a traversable along array, we need to see whether or not we could have gone... When we're going to move, get closest traversable along array will look for a traversable that it can go to in the direction that it's trying to go, right? The problem with this is that it doesn't matter how many squares in between where you are and where it finds. It doesn't matter if there are actual places you can go, right? So I think what we... in a sense, we could... we could just say, like, if I get rid of all this stuff, right? If we just say, look, get the closest sim space traversable from wherever we are. Oh, and I guess the occupying part here... I guess we do need this, though. So really, here we would want to do something slightly different, which is we would want to say... I see. So I guess I do see what this code does. All this code does is it tracks what traversable we're on. That's it, right? So it says, look, we're going to try to occupy the place that we're floating over. And the blocked part seems a little weird, but we'll look at that later. All I was going to say is, so this part here where we do get closest traversable along ray, I think all we have to do is clamp this. We just clamp this. In fact, I don't even really know why we would need to do that. I mean, I get... Oh, so you know what? I take it back. So we probably do just want to slap collision volumes in for these things, because now I think about it, you want floating people to be able to float over chasms. So we really do need to know the difference between walls. So forget it. This code is fine. I guess we're just going to leave it. So I guess what we do is in RoomGen, when we're placing walls, we should place collision volumes, right? So we want to be able to place collision volumes... and if we look, so if I go into the entity code and I draw what collision volumes we're actually seeing here, we can just go ahead and watch, right? There we go. Here are the collision volumes, right? And so for whatever reason, you know, I guess that's even much better than I was thinking. If that's true, then that means all of these already have collision volumes. So all we really have to do is enable the collision volumes to let this saucy gentleman collide. So I guess it's actually easier than I thought it was going to be. Of course, he stopped moving for some reason, which I guess I don't know why that happened. But Oh, because I accidentally deleted the head movement code. So I guess this code worked even better than we thought because all we have to do is give this fellow a collision volume, and then I guess he will collide. So I don't know. I guess it's better than I thought it was. That's so he's nice if the code is better than we thought it was. I'm a little surprised. So here where we do make simple collision volume, for example, this part right here, we would want to just add one for this dude. So you know, I don't actually know if there's anything special. I guess it can just use the same kind as the other one was using. I'm not sure there's any magic to it. We may want to change the size of it, or who knows what. Like that probably looks a little bit too small, you know. So maybe we don't want to do that. Maybe we want this to be more like, you know, something like that. Well, I don't know. Hard to say. But anyway, in theory, now I would think that collisions would now prevent this fellow from moving. I don't actually know that that's true, so we'll take a look. But we'll see. So it doesn't look like that collision was prevented, though, so I guess not. I don't actually know when entity collide set for any of these things, though. Because that's the other thing, like, if this flag isn't set. Yeah, so all of these are not set to colliding. So the other thing I think we would have to do is say that it was. And the only thing that's a little weird about that is I don't know that, I don't know if collides, like, I'm not totally sure why that's a thing. Like, I don't know why we don't just always have collisions. If there was some rational reason for that to keep that currently or not, I'm not sure. But it looks like, and they can still go through these walls, presumably because those are not set to collide. So I don't really know why. I don't really know why we have this flag. Because it seems like you would just not add a collision volume if something didn't collide. You know what I'm saying? So I'm a little bit. Again, we're just kind of paging this code back in. So we've said a bunch of times, like, I'm not sure why X happened, and then it turns out there's a good reason for X, or at least it worked better than we thought. So I'm not ready to say that it doesn't need to be there. I'm just not sure. I'm just not sure I understand what we were intending that to do. So when we call move entity here, you can see us iterating to try and move the entity. This code is probably crap. Yeah. But when we move, like, it looks like it's not gonna do this. So it's not gonna do this if we don't have these set. So again, I don't know why. I don't know why we have that flag. If I just turn off that flag, I'm curious what happens. Because it seems like just don't add a collision volume. I don't know why we have that, right? Looks like for some reason that gentleman can't get through, but I'm not sure why, because it doesn't look like there's anything there to stop them. It might be that this is too low, but at least, hey, we know that it is actually colliding. So in the makes simple grounded collision, I'm going to take a look at the simple grounded collision. Offset Z presumably needs to be slightly higher up off the ground so that it can float around. But other than that, it looks fine. If I go ahead and run, yeah, so I don't know why that person's being stopped there when the collisions are turned on. If I go look at it a little bit more closely here, like, it sure doesn't look like anything would be stopping. right? Like, that looks like you would fit through just fine. Obviously, that's not true. So I'm not really sure. I'm not sure what's going on there. If there's some kind of weird... Yeah, if there's some kind of weird thing, I don't know. But in terms of can collide... Yeah, I don't see a lot of reason not to just turn this off for now. So I'm going to see... I'm just going to see if we can remove that flag entirely. Because I can see having stuff that says what to do on collision. Like, I can see having stuff that says, look, when this thing collides, let it keep going. But, you know, you have to at least want collision processing to take place. Otherwise, why did you put, why did you put one on there? You know what I'm saying? So it doesn't make a lot of sense to me. So it just kind of seems like something must be up. I don't know. So if I were to turn this off completely, I just want to see what happens here. Here's us adding these flags to everybody. Yeah, I mean, I'm just going to turn this off. I'm just going to get rid of it. I think it's going to be redundant, and I don't know. It's just adding complexity for no real reason. So let's just get rid of it. Okay. And now we know that this saucy gentleman is stuck. And now we just have to see why is that movement code busted, right? Because there's no obvious reason why you can't move through there. And so, like I said, okay, so you know what it could be? If it's the room, if it's colliding with the room boundary. You know what I'm saying? Which would be right there, so it's that. That's probably what's happening. It's colliding with the room boundary. So I would suspect that, again, what we want to do there is just say, hey, when you collide with the room boundary, you just do whatever it is that you do when you enter that room. But you don't have to actually... This is what I'm saying. So rather than have this can collide, like, what we want to do instead is talk about what happens when you collide, right? And so we're effectively, I think, we want to replace that flag that was like, does it collide or doesn't it, with what is the response, right? So in here, we have, like, this response, for example, which is really horrible. Yeah, I mean, this code is very old and crappy. But this response here is like... is just like one thing we would do, right? This, I don't know what... This was for climbing up and down stairwells. This was like for smooth going up ramps. Right? This is so old. So in here, I think we just want to process a collision, right? So when this happens, we just want to say, look, don't just assume that we're going to do some kind of a, assume that we always check collision volumes, because if you didn't want to know when things collided, then you wouldn't add a collision volume, right? And then instead of what we were doing before, which is just always applying the same kind of collision stuff, what we want to do here is actually do something smart, whenever we see one. Excuse me. So in here, where we do hit this, right? This code is the code that stops us. So what we would like to do is have this speculative collide thing. We could actually, do something like this. Where we say, look, if it's not a room, then you can't go, right? That kind of thing. And so again, we want to start building this out, and so we kind of want to replace like that entity flag collides. I don't think we need that anymore. You collide if you have collision volumes. And then what we're going to want to do is have effectively an enum in there that says, when you collide with this entity, what is the action that we're supposed to be taking, right? And we may want it to be even more complicated than just an enum. But what we want to do now is say, look, when something collides, we need to take an action. That action may just be as simple as stopping someone from moving, but it may be more like, oh, we need to, trigger some kind of a combat event, because that's what we're going to be working on for the next few weeks, right, is like combat stuff. So we're going to want to know, okay, these two things collided. Maybe they can just pass right through each other, but maybe they apply damage. Maybe something, it's some particles effects happen, all that kind of stuff. We're going to kind of need to have, a more complex notion of what happens when two things hit each other. So this crap is gone. Like, I don't care about this at all. And so right now we'll just do this, but in just a moment, we will update this code to use something more complicated. And I want to say that we also might be able to collapse some code down here, because don't we also use these collision volumes for like camera, like lookables and stuff? So we might be able to like kind of roll those systems in together. But I don't know. So anyway, let's turn off room boundary collisions and see, and yeah, that was it. So now we at least know that these collisions are working, right? And so you can kind of see that dude even grinding along the wall there, which is nice, right? And I think that's it. Presumably now they also can't go through the snake. I don't know how to test that. I have to kind of, yeah, there you go. So that seems good. And I think we're okay. But the main problem we're going to have now, and I think this even happened just now, right? I think those two guys are like locked, is that like the collision code is super crappy as well. And so what we probably want to do is actually get some good collision code in there too, right? So fix the collision code, and then, maybe let's also put in, while we're at it, some like glove collision, right? Because you can see me punching through here. They both have collision volumes. We would know that the glove hit, and we should do something, right? We should, right? Yeah, hexadecimal integer. I thought exactly the same thing when I said that. So yeah, it was, as I was saying, like, that doesn't sound good. What can I say? So all right, so that's all good. So one of the things we could do here is also like change the way that the glove works to be an actual. So the glove right now, since I want combat to start being a thing we're doing here, the glove right now is not moving under physics. So you have to understand some basic concepts here. And, we've never really talked about them too extensively on Handmade Hero, and I'm not going to belabor them right now because we're just kind of playing with gameplay stuff, and it's not super important that you understand it right now, but it's worth putting in your head just the notion that in general there's kind of two broad two fundamental categories you can classify movement schemes into, especially when you're talking about from a gameplay perspective. And the idea here is that you can have movement schemes that are sort of based on a movement algorithm, like a prescribed way, a prescribed path in which something will trace out a shape. We generally think of these things, we use terms for them such as generalized coordinates. And what we mean by that is that there's some kind of value. Like for the glove, there's like the angle of swipe, and we just run that angle and in the glove swipes, you know what I mean? And it doesn't matter. There's no more complexity in the system to it than that. There's just a few parameters that describe completely where the thing is supposed to be. And by feeding those parameters into the system, you get back out the position of the glove, right? And it doesn't mean you can't do physics. You actually can do physics on those systems. Generalized coordinate physics systems are a very well-studied, well-understood thing. But what it does mean is that the system will always be constrained to occupy a space allowed by those generalized coordinates. So if the only thing the generalized coordinates can represent is that path of the glove, then we could start doing physics on it, but we would never be able to have it get knocked away from that path. It could be stopped on its way through the path and come back, right? But it could never be knocked totally away and that sort of thing. So it's worth understanding the difference between generalized coordinates, which are that kind of system, and then a system where you're just talking about straightforward, kinematic or dynamic simulations that just have like position and velocity, right? A lot of times these things are called like Lagrangian systems. I don't know if there's a really good term for them. Just rigid body dynamics, just general like the completely free formulated version of them. I don't know what the name is, because generalized coordinates you still do rigid body dynamics on if you want to. Like I said, we're not doing that here. This is purely kinematic. It's just setting a number and you get out the position, but you could have been doing rigid body dynamics on it. The corresponding way, which is just saying, look, we're going to have these things be fully 3D simulated. We're just going to completely allow that, and then we're going to try and constrain using either springs like the floating head or other techniques. We're going to try to use those techniques to enforce a type of motion that we want, but it's strictly an attempt to get that path. It may not get that path, right? It's just going to push towards that path, and either it gets it or it doesn't. So I think for this kind of game, all that was a very long-winded wind-up for me to say that I think in this kind of game, I actually want to simulate the glove as a free-floating body for a number of reasons. One is I want active glove control to be like a big thing of what you do in the game. So I want a lot of unintended, quote unquote, where they're quite intended, but whatever, consequences of the glove being a separate body not attached to the hero. For example, if you walk through this door without first like pushing the glove forwards, I want the glove to get caught on the door and come in behind you so that when you hop through, you can't punch right away. You have to wait for the glove to come in, right? I want stuff like that to happen in this game. Like the glove, managing where the glove is should be something that a good player does. The door example is pretty stupid because, it would take you 5 seconds to learn to always push the glove forward. But that's just like one example of things, that we could do. There's lots of stuff we could do where, keeping the glove in a particular position is something that the player actively learns to do better. So when they first start, they're crappy at it, and the glove is always in a bad position, and they're not getting as many hits off as they could, or they're not doing as much damage as they could because they're just not managing the glove very well. And then later, when they get better at it, they're really good at glove management, and the glove is always in a good place, and they know how to like sequence hits so that when they hit something, they know how to manage like the bounce back on the glove and all these other sorts of things. So what I'd like to do is decouple the glove. As the first step we're going to do for combat, I'd like to decouple this sort of like kinematic movement system we got here. I want to get that out, and I want to make the glove be more of an active management, where so you're kind of like when you punch, it's less of a like I push the button to punch, and more of a like I'm pushing buttons at times to control where the glove is. And obviously there's a lot of subtlety to that, but this is why I say, so design forward versus design backward, right? Go listen to some game designers. The ones that I tend to respect all say that you experiment with the gameplay ideas in the game and you learn from them. So I'm not going to say anything else about what we're doing because I don't know. I'm just going to assume that we will learn when I go ahead and decouple this from, when I decouple this glove from, when I decouple the glove from being kinematic so that it's floating, at that point I think we will just explore what kinds of control we can impart to the glove, and I will try to find something that feels like what I want the game to feel like, right? And like I said, that's my understanding from listening to the game designers I respect, of which there are very few. They all seem to say that. And nobody says go write a document out that like details all the things the glove's going to do. It's like, no. You can brainstorm and have a notebook filled with ideas, and that's great because you need those as raw materials for your explorations. Go nuts, it's fine. But when it actually comes down to the day you are doing some design that day, you never just implement something because your notebook told you to. You always have to treat it like an exploration, like the notebook was like a map of some buried treasure that you're looking for, but you're not sure where it is, right? So you need to just kind of explore and have like a feel for that. Okay, also, you notice we really need to fix our filtering on lighting. You notice like where we get nice smooth lighting in here and then the hard edge there, which we don't even really have an explanation for why that happens, right? And we sort of know something about how those functions fall off, but it's just kind of like weird that we have that issue. It's neither here nor there, but it's like a thresholding problem, right? Yeah, doesn't matter. So anyway, I'm going to go ahead and decouple that. So now where we have that glove, we've got this add player thing, right? And you can see we actually created a separate one here. And we've got this movement mode angle offset. And so we really just want that to not be true anymore. And all of this stuff just goes away, right? So it's just going to be in movement mode floating, which means that the glove is just going to do its own thing. And it'll just be kind of like, the hero has this glove. If I run the game now, because there's no controller on the glove, it should just sort of, move around with us, right? And you can, okay. I guess we reset those things. I'm like, what the heck happened there? All right. So hold on a second. So this must set that on the glove. Probably does. Yeah, so, okay, so the glove actually gets this stuff set. All right. So, forget all this, right? Like, we don't want any of this happening anymore. So all this should kind of go away. That goes away. And then in here, where we've got the movement mode floating thing, this is what we actually want. And so, we want this. We want this to kind of always be the case, and this right here wants to not be like rigid anymore, right? So this just wants to be a target, and we've got sort of that PDC nonsense going, right? Where if you look at the code for this DDP, we can just probably make this be like a function that you call, because we're probably going to want to slap some of that crap on there. PDCs are not great, but they get the job done. You know, they're okay. And so you usually start with them, and then you step up to something more hardcore when you need to. Okay, so in here, what I want to do is when we have someone who wants to apply a proportional derivative controller, we can just do like PDC, where you say, look, here's the entity you're trying to do it on, and then we have the coefficients, which they have names I remember, but it's been so long. It's like PS and PD. What are the? Let's use the standard. Let's just take a second and look up the standards. Launching a super crappy Microsoft Edge. So here's the proportional derivative controller entry, and I just want to look up. There's the standard terms. I want to use the standard terms here if I can. There they are. So it's KD. That's what I was looking for. So yeah. So if you look at let's see, KP for the first order and KD for the second order looks like KP. What is KI? Oh, that's for proportional integral controller. Yes, it is. I'm like, so why would we want that? No, we don't want that. So it's P and D. So KP and KD. If I want to be consistent with the literature. So our KP is here, and in fact, we can also just have like this is our standard one, and people can override it or something. But we can just say, look, KP applies here, KD applies here, and all you need to do is tell us like what did you actually want what did you actually want the target to be, and we'll try and get it there, whatever the entity is you give us. So that way we can have the glove be like kind of laggy and smooth behind, just smooth along with the body, instead of this, which rigidly locked its position. So we can set its movement mode to floating, and then I can say like, look, give a proportional derivative controller here to this, which is the actual like thing that it was trying to achieve, which will probably change in a moment here. But this is our target P, so we've got basically like a target P. That's the body location, plus this, nonsense of like where we're kind of going off of the, where we're offset from the hero. And so now we're just going to say, look, try to get there, but don't force it. Right? Before it was just like literally sticking the glove there. Now like the glove has to actually track, right? And so what we could do is set that to be like springy in a way, right? We can set that to be springy so it's kind of trying to trace out and get to the place where we said it should be, right? So if I go ahead and change what the KS and KD are here, KP and KD, sorry. If I have like a really strong one, so much stronger than the ones that we had before, I can crank up the stiffness on this particular, it's called stiffness on them, and it will hew closer to me the further up I crank them, right? And this is why I say you don't always want to stick with something like this, because you can get into situations where the springs are too stiff, and so we may want to change this to something else. But you can kind of see here how, like, if I want the glove to lag behind me, I can make it so that it's compare it to the familiar, right, which is using the other settings, and hopefully you can see sort of the difference there, right? And one of the problems that we have here as well is it's not going to match the velocity. And that's a problem. We really want this proportion to probably match the velocity as well. So what we probably want to do is have the body's DP in there. The problem is I don't actually know that we know what the body's DP is because I don't know if we compute it. We probably should always be computing it for this very purpose. But you can see here how like already just with that setting, I could keep the glove relatively close to the hero at all times, which is what we wanted, right? But that velocity match is going to be important. So I feel like that's something to put in there. And for those of you who don't know what I'm talking about, see, that's what I wanted to have happen, right? I kind of want it to be able to glide off of there, so I don't know that I want it to be that easy for it to get stuck. I want it to just lag. So we may want to have it roll. We may want to have a collision model that does a little bit more of a roll than that. Why can't that guy come through here? Oh, is it stuck to this dude again? Yeah, I don't know. Doesn't matter. Like I said, we got to fix our collision stuff anyway. So, we could do that. And then for punching, right, I just want to say something maybe along the lines of, I really don't want to set, like, angle attack swipe or any of that stuff. So really, if attacked, I don't know that we even care about that, really. Like, more what I want to be able to do here is just say, well, when we do if attacked, maybe we want the offset to be whatever the facing direction is. I don't care about this, right? I want to, like, push it in the direction of the attack. Which I don't know. I don't know exactly what I want to do there, right? But like something. So something like this. So when we get the actual attack, you can see like we've got like move right, and then we've got action for like doing. It's called sword for some reason, even though it's a glove. So I don't know why we kept that naming, but it doesn't matter. So you can see here we set the D sword value. So like I'm just guessing that like we should set the D sword value to be, or rather we use the D sword value as like an offset here. So if we look at how this is being used, you can see that we're like setting the facing direction based on the D sword. It's ridiculous that we don't just set the facing direction. It's just dumb. It's like welcome to calling ATAN2 every frame for no reason at all. It's like a Stack Overflow move right there. It's like some high quality Stack Overflow coding. I say that only because I literally saw a thing just the other day on Stack Overflow where someone was like, oh yeah, just call ATAN2, and it was a thing that you would never call ATAN2 for because you already had the answer. So this is some Stack Overflow, like to do like stop with the Stack Overflow quality. So we want to de-Stack Overflow that, but what I want to do here is I don't care about that at all. I just want to use that D sword value here. So I want to be able to add D sword, and this will just like however far out like that punch is going. And the only problem with this is I don't actually know like how D sword works with diagonals. Like it never gets normalized probably. So we probably want to do a NOS on this so that we can just say, look, if you're going diagonally, you don't get like more distance on the sword. So we'd have like glove dist, and that's going to be a thing that's a property of the player, right? They're going to upgrade their glove and have higher glove dist or whatever the heck. So like that'll probably come, to do like glove dist is probably a upgradable thing, So you've got glove dist, and glove dist is going to be how far away from the player you can get. So, maybe you can punch, 3 units away or some garbage like that. And I think this is, I want to say that that's a 2D value. Oops. So I want to say we have to 3D it first, because it's not gonna, you can't punch up and down in this game. You can only hit people on the floor you're on at the moment, and maybe that'll change. So it's weirdly laggy there, and I'm not sure why. I think probably because of collision weirdness, maybe. But anyway, so you can see, you can basically see what I'm getting at here, though. Yeah, I think we just need to fix our collision routine. I think it's getting stuck on things, perhaps. Let me take a look. Yeah. I mean, it's like skating right on the ground. In fact, why is it on the ground? Why is the... Where is glove float height, and why is it so tiny? So why is this not... Why is it not actually floating above the ground? Is it that it can't get off the ground? Like, what's going on? Yeah, like, what's the problem? Yeah, I don't know what's going on with that. So you can see here, like, if you want to punch, right? You punch like this. And you want that to be, like, pretty springy. Probably more springy than that, even. You know what I'm saying? Like, you really want that to fly out there. But again, so, you go through a door or something, like I said, I kind of want it to be that as you go through the door, it'll just get stuck, or something, to that effect, if you don't first, like, punch it out, right? You want to, like, punch it in the direction, so you want to manage, like, the glove movement. And then I'm imagining, I think I'm going to go fix that collision sector. Do I have time today to fix the collision sector? We started at 11, so I have an hour, so I might go fix the collision sector. So, if you punch through people or do whatever you're going to do, I'm imagining that, like, the damage would be based on the speed of the punch. So that basically, like, if you just run into somebody like this, it doesn't do anything, right? So that, like, doesn't do damage. You have to, like, have a certain velocity on the glove. So when you punch, the velocity of the glove will be, like, when the glove reaches a high enough velocity to do damage, it'll, like, get particles on it or something, right? So you know when a punch will do something, and otherwise a glove just does a push, right? Like, it would just push against something, but it wouldn't actually damage them. Just like a regular punch. Like, if you just push on something versus you hit it, right, it's going to be different. So I kind of want the glove to have that feel to it, if that makes sense. So we'll see. But yeah. And it looked like that was a little too far as well, so I might just switch it up a little bit here. But then let's go. We're gonna have to, like, improve our collision stuff there and all that. But yeah, it's still really weird how the glove, like, gets stuck on things like that. I don't really understand what's going on there. So again, I want to fix collision routine so we can get that out of the way. But, like, I don't know, like, it was like, it felt like it was getting stuck on stuff, but it's kind of weird. I can't really see it actually happen. Like, there it's looking correct, right? And again, I really don't know what the PDC max value should be. Are these movement speeds capped, by the way? We should go look, because that might also be why you can't get... All right, so I'm gonna look at this because something's weird. I don't even think that is the collision detector. There's weird stuff with the floating mode. I don't get it. I'm not sure what's going on there. It doesn't look good though. Um, so like, what's up with that? Does the glove do anything else? Like, are there other things happening with the glove in here that I'm not aware of? Um, So this might have something to do with it. Although, since movement mode is always floating, it shouldn't be. Um, so it does only seem to be that, though. I mean, there's no... I guess, and D-Sword doesn't really get used anywhere either. So... So I don't know about that. It just seems to be behaving rather oddly. So I don't know what to make of that. Separately, we probably do still want this. But yeah. It just feels really odd, is all I can say. It doesn't. It feels like there's a stopping point in the middle as it moves over the first square, and I have no explanation for why it would do that. Because it looks like we're just using a straight offset. There's no, like... There's no, like, additional thing happening there. Big stretch. Okay, so that's just weird. So I guess the first thing I would say is, because I don't know much about this move entity call, except that it's a piece of crap, what the heck? Does somebody want to tell me what that is? Okay. Hold, please. So what was that for? Like, that literally does nothing. So... if the player delta length is greater than the distance remaining... So this was something that, like, we wanted to clamp the movement of some entities or something? I mean, whatever this was, it sucked. Like, what would be the point of that? Like, because we should be doing a better, like, physical movement here where we just say, look, this is the place the player was trying to go to. Put them at the closest location to that you can. Not player, but whatever. The entity was trying to go here. Like, this is where the entity is supposed to be. So put it as close as there as you can without causing a collision, right? I mean, that's all we really want to do. So I'm just gonna take a hatchet to this routine because frankly this sucks and I don't want it. Um, I I guess we want to say that maybe. We'll see. All right. So this is gone. Like that's got to go. This whole thing is stupid. Like this is dumb. But um yeah, I don't like any of this. We're probably gonna hatchet this up quite a bit. Yeah, this is all horrible, and I don't like any of it. All right. So I think what we're doing now is we're just gonna rewrite this routine. This looks like something that tries to change the facing direction based on how an entity moved here. I'm gonna say that will get handled elsewhere anyway. It already is, and it was commented out. So that was fine. So this was trying to do like a branch and bound kind of thing, it looks like. Which we, again, don't really want. So I mean, yeah, let's take this step by step. So if you take a look at how this is working, we're going to move entities, and it looks like this is set up to move entities like one at a time, which is fine, because this game isn't really about physical simulation, so we don't have a lot of problems where we want to solve stuff like, you know, 4 entities that are all kind of moving, that are all in contact with each other or something like this, in which case this wouldn't work very well. But if we take a look here, what we're doing is we're saying, well, here is where we expect the player to end up, right? Like, we're taking, this is standard, this is 1/2 AT squared plus VT dt, right? I should say 1/2 A dt squared plus V dt, meaning the standard, like, what's the position going to be after we apply the velocity and acceleration over the time step that we've been given, right? And that's all that is. And so what we want to do here is say, okay, if we know that is, and to be honest, you know, we probably want to compute here in addition to a delta. I'd like to just say like where the desired position is. It looks like we compute that inside the loop. But I'd kind of like to just make that be a main thing that we actually like said we were looking for in general. So we're gonna call desired position just a thing outside, and if we have intermediate targets, then we will deal with those later, right? I don't know what this is about, and I don't much care, because we're going to try to place the player where we're placing them. Whether or not they moved is not really the issue, right? So I'll keep this iteration stuff, although I don't know how many iterations we're really going to do, but I guess we'll find out. So this says this is an optimization, but that optimization is no longer there, right? So we can get rid of that. So that goes away. And so while we're in here, it looks like we're getting the dimensions and centers of our collision volumes, right? And we're doing a Minkowski test. On these, which is fine. And it looks like this is using some kind of crappy wall code thing that I guess we wrote a long time ago to just go like, hey, let's test against like bumping into these things, I guess. But I don't know that we care about that, right? So my guess is, look, we're going to have a couple different problems here. One of the problems is what happens when we want to find how far we can go in a particular direction. And that is, that is just a problem with the fact that we can just raycast and know the answer to that, pretty much, right? So the more interesting problem here that we have to focus on is the fact that we do want things to slide. So we want things to slide against surfaces. And in order to do that, we're going to have to make sure that we use something like a cylinder or a sphere for the shapes that we move around. So we can totally have square shapes, like rectangles like we have for like the walls, because they're trying to fill a rectangular space and prevent you from moving through it. But we definitely want to have the shapes that we move through the world be smoother, because if they're not, when you have like two cubes that hit each other, right, you have just two flat things. There's not a way for it to clearly roll off edges. That's why we use things like cylinders and spheres for collision in games, because we want things to roll off each other at the edges, and they won't do that if they're flat. So in terms of like, how we want to deal with that, I think we'd like to change probably. I'm just thinking to myself. I think we would want to make it so that things that move are considered to be spheres, because I'm just thinking everything that moves in this game with collisions is like floating. So we probably want everything that moves to be a sphere and everything that doesn't move to be a cube. Well, a right rectangular prism, right? So I think that's what I would say, like, I think that's what I would say. So I'm going to enter this assuming that that's the case, and we'll see. So I don't care about an epsilon here. Hopefully we can get away without one. Epsilons are usually not great, so we probably want to try and write this code in a way that doesn't really use one to the extent that we can. And so when we look here, we're going to iterate over these entities, and I think what we want to do now is figure out how we can do sort of a closest point placement test based on the entity. And, I would like to do something that's as close as possible to sort of maybe what I did in the witness, where I'm placing entities the furthest that they could go based on the distance the distance from uh, I want to put them at the closest point they can get within a search region that is the closest point to the point they were trying to get to, is the way to say it. And in order to do that, I just need a way of locally, for this particular whatever the thing is that I'm looking at, I just need a way of figuring out where that point is. And the reason it's kind of tricky, and I might want to go to the board for this, the reason it's kind of tricky is I don't actually know offhand what the most efficient way to do that is if I'm not going to actually construct a localized grid. There's probably like a hackier way to do it that just gets the answer for floating things, as opposed to like the one I did in the witness, which was much more complicated. We should probably just do this on the board. All right. Sorry that took a second there. I guess I don't actually know. I should just check to make sure everyone can hear me okay. I wasn't planning on doing any board stuff today, so I didn't have it set up, so I had to quickly get it set up. But let me just check. Can you hear me? Cool. All right. So what I'm basically talking about here is pretty simple in theory. It's just kind of hard to implement. And again, if you go look at the talks I've done on the witness collision detector, they talk a lot about sort of the goals of doing a hardcore one of these. And in this case, we don't really need a hardcore one of these, but I would like to sort of use the same principles because when I've thought through the problem, which I did on that project, to me, this is the only logical conclusion about how to do these sorts of systems. So I kind of want one that hews as close to that as possible without really being quite so hardcore because it doesn't really need to do the same kind of stuff that the witness needed to do. But here's the essential issue. So let's suppose that we have some kind of a blocking piece like a wall like we saw before. And we have, something that we're moving, and the idea is we want this thing to be able to sort of slide. So, as this sphere kind of comes up through here, at some point, this thing, if we're talking about moving the center here, at some point we can no longer go, if we're talking about physically, we can't go because we would interpenetrate. And if we just want to solve that problem, it's not quite as hard because we can use, for example, the Minkowski sum like we've talked about before, where we can just say, look, a sphere plus a cube is just a rounded cube kind of thing. So we could just do a raycast against the rounded cube and find the point where we have to stop moving, and that would be our answer. But the reason that it's more complicated than that is because we don't want to just stop when we hit something. We want to keep moving in the direction that we're going, minus whatever the actual stopping part was. So if this was stopping us, we want to stop moving that way and start moving this way when we hit, and we want that to happen automatically. So we don't want the player to go up and just stop against the thing. We want them to glide along the edge. And you may ask why we want this. Who knows? We don't know why we want this. We just know that when you implement something that works like that in a game, it feels better to play. So we don't know why it feels better to do that. We just know that when you do it, pretty much no players that anyone's ever seen prefer something to just get stopped immediately on a wall and then they have to push up to keep going. They all prefer if it just kind of, when they hit, if they keep pushing in that direction, they just slide and go off it and then, go like this. If you don't implement a system that handles this, then your game feels sticky. It feels like things are getting stuck to surfaces all the time. And, if you want that, great. But if you don't, and you pretty much never do, you need a better answer. So the problem that we get here is that if we start to do too much fanciness, if we actually implement these things literally, so if we implement these things as literally, I'm going to do a movement to here, see that I've hit this thing, then try a movement to here, and so on, you end up in kind of a nasty place where you're trying to do lots of little movements, and it's very easy for the numerical imprecision of the system. Because remember, each time you do one of these, you're slightly numerically imprecise. You're never getting an exact answer. It's very easy to end up in situations where, especially when you have stuff like 2, pieces or 3 pieces like this that are all abutting, it's very easy to get into situations where you end up putting something inside another thing, or you don't quite get the numerical stuff worked out and things get stuck. So you need to be very careful when you construct these systems so that the thing that they're actually solving for and the way that they're solving for it is very unlikely to produce bad numerical outcomes, and that can be really difficult to do. So the kind that we had in there from way back when was just a super crappy collision thing. I think we called it crappy at the time as well. And so what we want to do is start thinking about something that's better than that, right? Now, what I was saying before is I like systems like for the witness. I like systems that have. I'm erasing this because this is no longer. We don't need any of these diagrams. These are just me kind of idly explaining stuff, right? This will not be part of the exam. Okay, so basically what happens now is we need a system that has a good sort of overall structure for producing results that we think might be good, right? And to me, the way I like to think about these is at any given time, we start with the entity that we're moving, and we produce a candidate position that is where we would like it to be. And instead of thinking of this as a problem of tracing a movement pattern, which gets into that iterative, like I hit something and then I go, and it's not clear where that ends. Like, I could keep bouncing around in there and never really, and do I just cap the iteration? I want something where I know when I'm done. Like, I want to be able to do an exhaustive search over something so that the definition of when I have finished is clear. Right? I want a stronger metric than I don't know, I just started searching in that direction and did stuff. That to me doesn't feel very good. So what I want to do is I want to do something where I produce a candidate location, and then which is where you would move if you didn't collide. And that's free because we're just adding the vector, the motion vector. We know we will go to this position. So it's trivial for us to find that. And then what I want to do is say, in the presence of some kind of collision where we know that if we were to put the thing there, it would end up being, it would end up creating a situation where we would overlap in a way that we don't want to. Then what I want to do is search for the closest continuous place where I can place the entity, right? So what I'd like to do is then say, okay, and you can see the really simple version of this would be to just sort of look for places I could put, right? And that would be like a search and T kind of situation where I basically just look along here for places I could put. And why don't I want to do that? Well, because again, it doesn't work for sliding. So if I do this and I just start looking along this line, I will find this location here where I first hit, right? But that is not as far as I could have gone. I could have gone as far as here, right? That would have been a legal motion for me to do. And if the total path length here is less than the motion vector, that would have presumably been legal, right? So, maybe this is a little bit further back. You know what I'm saying? So I'm trying to think if there's some way of doing a similar sort of thing to the witness, which is producing an exhaustive search over some amount of space, but that doesn't put me into that situation, right? And so here's, some things that I'm thinking about, right? So if instead of I'm trying to think of like how we would phrase this here, right? If instead of thinking of this as a problem where we update the position we were at and then look for places to go, what if we turned this into more of like a pathfinding problem, right? So we would say something like, I'm just trying to think of exactly how this is formulated. So we know that we can't move backwards along this line, right? So the player, if the player was faced with an obstacle that was literally 100% perpendicular shaped to the direction of motion right against them, so if it was like this or anywhere in here, then it would stop, and it should actually stop, right? But anything else, any other deflection angle, we want them to start gliding along that, right? So if there's another, if it hits something and that something is tilted like this, it wants to go this way. If it hits something and it's tilted like that, it wants to go that way, right? So every time we put an obstacle in, we're effectively creating like a glide angle. And the problem that we would get, right, that makes this kind of an annoying problem, is that the problem we will end up with is they can stack. So, you'd hit one, you'd glide, but then there might be one here, right? So you'd hit that and you'd glide, or you'd try to glide upward and you'd hit, right? So what we want to do is figure out some way we can sweep over all of the things that we might hit. And we assume that eventually we'll have a spatial partition, right, that will make that an easy query. So we're not worried about that. But we take all the things in that are ostensibly going to affect our movement. And what we want to do is be able to pile those into something that allows us to find what would be the closest point we could actually get to that's closest to our ending position. Now, again, the way that I did this on the witness was I built a localized grid. So you would take and you would overlay something like this, right, onto the system. And you would, as you sort of got obstacles that came in, you would sort of like fill in pieces of the grid so that you knew when you were actually then later trying to move, you would know like what were the closest, when you tried to get somewhere, it'd be like where was the closest place you could get relative to that. So if that thing actually got filled in, you would find the closest point by searching through the grid for wherever was the closest point to that. And I'm just trying to figure out if there's a way to do that more simply for this type of a problem where you're just where maybe we don't care as much about the robustness of it, as long as we can guarantee that things don't get stuck. We don't have as we're not trying to reach as high a level as quality as maybe of guarantees about what happens in the system. But still sort of roughly keeping this, right? And so I guess, if I were to, So let's suppose we start plopping things down here, right? And we've got some object that's trying to go through. And we know that, like, as this object gets to, like, here, right, we want it to start sliding. So what this effectively... And the reason that this is even more complicated is we want it to be able to go around this if it had enough momentum to do so, right? So if it could have gotten around here, we probably want it to do that, right? Because we don't really want you to get stuck on edges, right? We want you to be able to go around. So at a micro level, because these are very small movements, right, it really wouldn't look like this. This would be a much larger thing, right? And this would be like, a much larger thing. And if there was a small amount, right, if you just had to just move a little bit, you just want to glide through that. You don't really want the player to get stuck there, right? So I guess what I would say is can we just treat this as a pathfinding problem? I think I'm just going to try it that way. So suppose we took and we just said, yeah, like we're going to literally do that. We're going to take this guy and we have the endpoint and we create a path to the endpoint, right? And then when we slap in something, so we go ahead and we intersect the current path that we've got with the object that comes down. And we find, right, that it looks like this. So we do the raycast, we find that we hit here. So then we just say, well, whatever surface we hit, we're going to do like a path update now, and we'll raycast in the direction of that to see how far. Well, I guess we don't really have to. We know here, right, what the distance to the edge of that thing would be. So we know that it would like come to here. So we like update the path to look like this, right? I'm just spitballing here. So we update the path to look like this. Now the problem that we have is we don't know whether this particular point is actually legal, right? Because it may be that transiting through that point was actually prevented by some other object we already processed that doesn't hit this line. So maybe there was an obstacle here. This could go straight through it and it would be fine, but it can't actually handle the fact that you wouldn't have been able to go through here because there was something there, right? So maybe what we can do is, instead of thinking of this as a problem where we move and we do like stateful motion like that, what if we just treated it as same basic idea? So we're still doing the crappy kind of we raycast, we hit something, we consider that a new position. But instead of thinking of it as updating the position and then we do a new raycast, what if we just think of it as a continuous path? So we say we restart our paths through the system after we do that with this as the path now, and we raycast these legs to see if any of those hit. If one of them do, we insert a new leg into the path, right? And we keep doing that. And then we just take the longest, when we're done, when we're doing n paths of that, we just take the longest legal one we can find. Right? And I feel like that's a little bit better of a structure for it, because now we can look at that path at each iteration and know that we at least know we're always going to re-go from the... We won't get into those weird situations where like you accidentally numerically like wiggle your way through something, because we're always just keeping these actual segments on hand. And we can even just say if there's a segment that looks like that, like if a segment is too small, we just throw that out, right? It seems like potentially a better framing for the problem. I don't know. It might not really be. It might be that it doesn't actually improve our odds at all. And that you could have just done exactly that by just doing it incrementally. Yeah. So let's talk about a couple other things here. So the other thing we need to make sure that we have here is a way that, again, if we construct this path by using a displacement method, we could probably come out with ways that we always push away from obstacles, which is the other thing that we want to do. So we don't want things to be able to get stuck. So maybe raycast is the wrong term. So maybe what we want to do is say, look, we can test segments for overlap. When we test segments for overlap, what we do is we insert a point, and the point we insert is the one that's like, however, like we sort of do the raycast, but really we're just inserting a path point that is a known good distance away from the thing that we're at. We insert the path point there, right? And also the path point, you know, we introduce the new segment that we're going to start testing, we know that those are at the safe locations of this thing. So like that way, if you were already inside the thing, like let's say you end up getting stuck in the thing for some reason, right? For whatever reason, like the entity system just farts and it like accidentally puts somebody inside a collider, right? Then you say like so this is what we want to do. Okay, so we say that the person was trying to move, right? And I guess this is the tough part. Let's say they were trying to move that direction. I guess maybe it's fine that that wouldn't work. So, but then they try to move this direction. So they are trying to move out, right? So now what we would do is say, well, okay, we tested this segment, right? And the person is inside the I don't know, cube, whatever you want to call this. The person's inside the cube right now. So if the person is inside the cube if the first point of a segment is inside the cube, right? Then we introduce a path segment that is outside, that is the legal place outside the cube in that direction. That's the new path segment. And then when we evaluate the path, we would just say, well, if you're inside to begin with, then we do allow you to pick an outside point. If the next segment on the path is outside, you can pick it, right? So we could actually use that as something reasonable if we have a way of testing and saying, are you inside or outside of this thing? And maybe we just skip the raycast part altogether and just treat this as an overlap problem for now, so that we don't ever raycast. We just say, are you inside or outside, and make sure that it works with that. You know, it's not great. It's getting there, but it's not great. So if I am like summarizing this, right? So we start with a point that's either in or out, and another point that's either in or out, right? So we have, you know, in, out on these that we test. And then we have a place, you know, a segment that goes between them. So the reason we need a raycast is to know whether this segment would be legal, because it's possible that it's not, right? We need some way of knowing if this segment is a legal segment. Like, could you actually move along it? And I guess what we're saying is if the segment is in and this is out, then we just don't bother, I guess. The problem is you could end up with issues there as well. Like, you kind of don't ever want people to be inside stuff, but I'm not sure that we want to be robust enough to never have that happen. Because again, then you're into witness territory, I think, at that point, when you make that actually a hard requirement that you can prove. So if you start, I want to find the closest point that I can put this thing at. And so I can start searching along this thing. I could just use overlap testing to say, well, you know, we could just overlap test at discrete intervals along this thing and then find the furthest one that we can. And, you know, if we're going from in, then we're looking for the first out. If we're going for out, we're looking for the first in. And then we place the point at that transition, right? At that place where either on the outside or the inside, if we were going from in to out, we place it on the far end. If we're going from out to in, we place it on the near end. And then, you know what you hit, so you should be able to then do an update of where your path would go. And I think you always kind of just know, you just Well, you might not. So, for example, you could say, well, the path just now looks like that, but really you could have maybe done it if you'd gone just a little bit further. So I'm still not quite happy with this. It's still not positional enough for me, for my tastes. So if we assume that things that are moving in general are always like spherical, then you can think of the thing that is, the actual shape of positions you were trying as being that sphere, right? Now, let's suppose I'm going to need some more space here. By the way, somebody out there who's like an engineer, physical, like of physical like hardware stuff, please invent the instant erase light board. Like, I guess maybe there's no point to it because we'll all be wearing AR goggles eventually with like, and it'll just be a position thing that I draw in the air. Although, man, without haptic feedback, writing is going to be like so even. My handwriting will, you think my handwriting's bad now? Whoo boy. But yeah, I mean, or solve the haptic feedback problem, I guess. Could be the other thing you could do. And then we all wear like annoying VR goggles. And we have to use our Facebook login to write on a whiteboard because, Silicon Valley is so amazing and they're so interested in humans and making sure they can communicate well, and they definitely don't do anything like primarily concern themselves only with making money, because that would be nuts. But basically, like, this process is annoying and takes forever, and it doesn't ever get completely clean anyway. And so that, if you could just solve that problem somehow, like with some kind of magical, like super easy to remove ink, so it's just quick, or better yet, like electrostatic, like it's like an Etch-a-Sketch or something. You push the button, it just goes clink, and it all falls down, right? I don't know. Please do it. It would be great. So I'm taking a total. I'm just continuing to kind of go through here and think this out. So suppose I've got a motion plan where this thing's trying to go here. Well, we know that, like, if we're assuming that you can only go, so if that was the amount of like movement you had, then we know that you've effectively got sort of at the micro level, right? Because remember, these are very small distances. At a 60th of a second, things are not moving that far. So these are pretty small, but you've effectively got a hemisphere in which you could move. So this is the move we're trying to accomplish. And we have a hemisphere of possible positions we could end up in. But we fundamentally know that because we're saying that the person only, well, person, the entity, could be an inanimate object, the glove, whatever, could only move this far, whatever this distance is, we know that, like, whatever that distance is, they should never be able to get any further than that, right? So if I'm running this way and I hit some surface I'm supposed to glide along, well, we can never get any more than that, because that would be how far we would go if we had been going straight that direction, right? And furthermore, we could probably classify this into something even less pronounced than a hemisphere, because since you were pushing in this direction, we would also assume that the thing that you hit is absorbing some of that. So you might also say that, like, you know, if I'm pushing in this direction and I hit something with that normal, that actually you should get like the cosine fall off of the speed. You know what I'm saying? So like as you go this way, it might be that this is really more like, you know, that, right? So fundamentally, we know that we're only looking in like a pattern that looks like this. And what we really need to do, like the best possible thing we could do is, and unfortunately this is 3D, so it's actually a thing that kind of looks like a nose cone of a ship, right? It's a thing that actually looks like this, right? So the nose cone of the ship, right? We know that we have to, the placement of the entity at the end of the day will be in this space because it can't be anywhere else, right? If it was anywhere else, you would be moving the player in the opposite direction that they asked for. So it has to occur in here. It can't occur like back there. And so when we are looking through this, what we then have is we have a series of obstacles that come in that prevent the player from going into certain regions of this space. So let's suppose now that I come in and I place this thing down, and again, we know that it's Minkowski, right? Because if we're talking about this as points we can place, we grow this rectangle by those spheres. So now we know that this shape, right, comes in and blocks off this portion. So now we know that actually the place we would put the player is actually here to here, right? And the closest point is wherever the closest point is in there, right? So at the end of the day, I'm wondering, maybe we just do this almost the same way as we do it in the witness. I wonder if we can just treat this as like a small scale subdivision problem. Like, assuming there's not that many entities, you know, how many entities are really going to be in just that one location? You know, like 10, 20? Not very many. If we just said, what if we just treated this area as a locally, like, subdividable place? And the 2D version would just be like, okay, so we create a little, like, you know, maybe we even treat it like a quad tree, right? So we just say, okay, we overlay the grid on top of this, and maybe we're feeling like super saucy, so we just like align the grid with this thing. So actually it doesn't look like that, it looks like this, right? And then we just go, okay, which of these things are in or out? So we iterate over each entity and we perform the overlap test, and the only thing we need to know is partially covered or not. Like, is there, or I should say, is there any place that's still open, or did it completely cover? And completely cover is pretty easy with these convex shapes. I should be able to write a pretty fast routine that just says completely covered or not. Anything of these that isn't completely covered, right, survives to the next round and gets like subdivided, right? So we could do something like that and discretize the space to the point where we actually can pick a place. And it would be an octree, you know. So it would actually, you know, it would actually be 8 because we're doing this in 3D. But we could actually discretize the space. And the only hard part at that point is that we have to make sure you can contiguously get there from where you started, right? So from where you started, we have to make sure that you could actually get there. And I'm kind of thinking to myself, that's not even maybe that hard. So actually that might not be that hard. So let's suppose that we do this thing that I'm talking about, right? And we say, okay, let's start with 2 cells, the place we're at and the place we're going. And I'll just draw this in 2D, but we're going to have to do it in 3D, so it'll be a little harder. But what we say is, okay, we're going somewhere. And so we place 2 cells down, and the cells look like this. Right? So we're going from here to here. We run the overlap test, and if we get nothing, so if it just says nothing occludes these at all, right? Then you're just done, and the entity goes. Yeah? Now, if one of them says there's nothing, then great, we just keep that cell. But if another one says there is something, we're like, okay, like let's say this one says there is something, then we're like, okay, we have to subdivide this cell into more cells, right? So then what we do is we take that cell and we say split the cell up, right? And the problem is I don't like that subdivision because the point is then at a intersection. Which is fine. Okay, so we do this slightly differently. So we say, okay, we're going from here to here. These are going to be the centers of the cells. Right? I think, unfortunately, I'm still going to have the same problem. There's got to be some way to do this subdivision clever. It's just not clicking in my brain. Because fundamentally, we need a way of subdividing. Maybe you subdivide 9s. You subdivide on 9s. So, you do this. And then when you subdivide like this. I don't love it, but I'm not sure what else you do. Because if you don't do that, it seems like you're always going to split right on where your point is, which seems bad. I don't know, maybe it's not. But anyway, if we subdivide this and we just keep subdividing it down by the reachable cells, so if it's like, oh, it's still overlapping, eventually we're going to end up with a discretized version of the space. At each time through, we just throw out cells that you can't reach, and we stop subdividing them, right? Eventually, we get a version that's at a resolution where we can just pick the closest one and be done, right? I don't know. We could do this. Yeah, and then you would literally just iterate over these. In fact, you could even do it as a single check. For spheres, this would be very simple. For the rounded rectangles, it'll be a little bit harder. We could do this. And so then this has the nice aspect of you're always picking positions that are actually legal, right? And so my only concern is I'm not sure what the subdivision scheme is that keeps you from putting the points. I mean, I guess you could just pick a weird like offset of the thing so that you knew that it never would be, but that's a little odd. I don't know. But you don't really want, you usually don't want your, main points of interest, things you're asking about, to be like right on the boundary. Seems like you're asking for numerical problems there. But, so if you took something that looked like this and you're like, how do we align this so that subdivisions don't keep causing problems? I'm just fundamentally not sure how you do that, right? So one way to do that is to just make it slightly off. So like, it's aligned like that so that like you never really get down to the point where you would ever, by the time you subdivided out that far, you were done. So we could do that, just it's offset slightly. So the cell is like whatever the smallest cell size. So let's say we end up with a small cell size. It's like, oh, we subdivide down to that or something. Then you just say, well, that's how far off we are. So the main problem I see here is with cell tracking. And so, oh, you know what? So here's the other optimization we can use. So this is great. So the nice part about this is we never really have to remember, do we? Because we never have to actually keep these cells around. So we can avoid storing them and processing them in any way because we can just remember the connectivity because that's all we care about, right? All we care about is the connectivity of the cells. Yeah. So we only need two things from this, right? We need the closest point to the destination. So closest to dest. So as we're doing this subdivision checking, we just need the closest point to the destination, and we need the connectivity to the next level up. Connectivity. So in other words, when we process this cell for subdivision, we don't care at all what the pattern of cells is after we're done processing it. We just care about whether or not, you can get from any particular one of these to any other particular one of these. And furthermore, we only really care, like, we're not going to do like entry and re-exit. Like the person can't go out here and come back in here as a legal path because that would require them changing the direction 180 degrees, which we're not going to let them do, right? So I don't think we care about that. So the only thing we care about is for each edge wall, which edge wall could you have left through, right? And the problem there is we do care sort of on the smaller scale about like, which of these you go through, but we only need the edges, right? We only need the edges. It's still a kind of squared connectivity problem, so I'm still not sure it's great. If you do the one with the here, where you're starting, with the starting position in it, then you know the places you could have left, right? Which means those are inputs to the new system, which then it knows where it could have left. So I think you can always propagate. If you just choose the starting position, you do all the subdivisions, you find all the edges you could have left on. Then those get fed into whatever the next two cells are, the two neighboring cells to that one. And this should be true all the way down, right? So you say, we've got the connectivity, but we really don't care about this. We just care about exits,
right? So you subdivide down and you remember what the exits are. So eventually you're looking at something that looks like this, is your furthest subdivision down, right? And like it turns out this one's blocked and these two aren't, right? So you know that your exits are here, here, and here. And your closest point, you know, if this was where you were trying to get to, your closest point is there, right? So then you just feed that information up to the next level. So if that square, right, if this square was here, then when you go to process this one, it has an entrance of here, right? So it knows that if it actually had this solid and this solid so that it can't actually get to that square, it knows that there are no exits but here because it couldn't get to that one, right? These aren't connected. So then when you look at the final one of these, right, you'd call this one only when you finished these two, right? So you do the one you're in, then you do the two that neighbor that one, right? So you do the two that neighbor that one, and the two that neighbor that one, well, they came in here, so they actually have both of these. So then you know that these are the entrance cells, here and here, right? And then you would look and say, okay, well, I can leave here, right? So you know what your entrances and exits are. So now you've got that, all of those, as what you would feed into your neighbor, right? So does this work? I mean, the other way to look at this is it's just you change the enlargement radius of the sphere and you think of it, you know, if the cells are too confusing, you know, don't think of it as cells, right? So you start out and you've got these two positions. So it's back to my old path sort of thing, right? And you make the spheres enlarged, or you can enlarge either side, doesn't matter. You make the spheres enlarged so that they cover the entire distance, right? So maybe your first check is actually a thing that checks to see whether it could go the whole way conservatively. If it can't, it subdivides and checks two here and here, right? And if those are fine, then it's done. If it can't, right, it keeps adding more. And when I subdivide down, right, so if it's here and here, we actually subdivide out to like a more like this, right? So we subdivide positions. So we are actually standing. Instead of using cells, we just consider it as standing on the actual quad tree, or octree in this case. And we just keep subdividing the octree down with positions we know we can stand on while there's still a connected path to the destination. While we still know there are potentially more ways to get there. So I kind of like this idea. It just may be too complicated. I mean, not too complicated. It may just be overkill, right, for what we want. So I think I want to sleep on that. We're probably out of time, I'm guessing. So I probably want to sleep on that. So let's just go back and maybe call it a day. And then next week we'll think about if we want to do this or not. That's my thinking. Yeah.
All right. So are we're out of time. So I think we're out of time for now. So that's my thinking on this. Um, so I'm not gonna really make a decision about this either or. But I want to just kind of like think about it. Any questions on what I was saying there? Wouldn't this allow longer paths than the original since you could still reach the goal while going a longer route? Yeah, so again, when we actually evaluate those, we can, if we want to, like, put some constraints on the total distance, but remember, these are micro movements. They're pretty small, right? So we may just not want to do that and say, look, there's flex in how the player or the entities move so that if there's a little obstacle and they would have had to have done a little thing in there, that's fine. Because remember, it's a 60th of a second or something that we're talking about this motion. It's a very tiny motion. So if we need them to like kind of go around something, it seems like it's fine. So I don't know that I would want to clamp it because I don't want the player's not thinking about that, right? They just want it. If it looks like they could go, it should just go at full speed, right? That's my thinking at the moment anyway. Has there been any advancement on the 4 simplex case of GJK? So I don't know. I haven't verified it. I want to say that Dirk Gregorius had some stuff on that because I remember going out to dinner with him and Jay one time, and he was saying some stuff. But I haven't looked at GJK in a long time, so I don't know. Ask Dirk. Why not just move the character to the closest legal point of the desired endpoint? Because of gliding. That's the whole thing I was saying with gliding. So the part that the player wants to end up at is not actually just the closest point. If there's something in the way, they want to glide along that something. Couldn't you squeegee the light board? No. Like, basically that's what you're doing with the microfiber cloth, and as far as I know, it doesn't really help to be a squeegee versus a microfiber cloth. In fact, the microfiber cloth picks up things almost better. So maybe, but I don't think so. And plus, it still takes a while. You'd have to like get you'd have to dunk a thing in and pull it down, and then dunk a thing and pull it down, and dunk a thing and pull it down. And maybe you have a good trough for the runoff, and it's fine, and it's probably faster than what I'm doing. So you might make an improvement, but it's not the instant clear. I want the instant clear. That's all. I mean, not the closest point of the path, closest point of the path. Yeah. So, that's literally the algorithm I was just describing. So yes, That is what we want to do. The problem is, how do we find the closest point that you can get to? Because remember, if you literally just take the closest point, then the person might be able to get somewhere they shouldn't be able to get, right? Because you don't know if those points were connected. You know what I'm saying? Now, we could try just doing that anyway. Like, we could say, we don't care, right? Because we're only going to place slow enough moving things with large enough objects that we just don't care. And we could even subdivide movements into small enough increments. So maybe we should do that, right? So that we don't have to worry about connectivity. We just do subdivision to find the closest point, and that's it. In fact, Volcanic Popsicle, you said that's probably a stupid question, but actually I think your stupid question is not stupid. I think it's very smart, and probably I should consider that, right? I should probably consider going, look, we don't care. We're just going to say we know the sizes of collision volumes. So we're going to subdivide motions into pieces that are appropriately sized. So if something's moving really fast, we just do a few iterations to do the placement, a few sequential iterations, right? Or we just clamp velocity to that speed. And then we say, all right, all we're going to do is look for closest point. So we just subdivide into cells and we just look for the closest point. And then we place you there. And we don't care if it's contiguous because we assume that there can't be microchannels of that size. Love it. Love it. Love that idea. Change what you said to, that's probably a stupid question, to, I have a great idea. And off we go. Just go edit your chat message. I know you can't, but if you could. So no, again, frame stutter is not a problem here because, like I said, we just take a look at. We can artificially say that if we need to move more than a certain time step, we just do multiple rounds of this, right? Because the only benefit to not subdividing the problem is speed. So if actually we can get a massive speed increase by saying we need this bounds on the size of the search space, then it becomes better to just run that a few times, right? Because each iteration, if you need to run 4 iterations of something that's 10 times faster, that's a win, right? So I think we could make something that just finds the closest point run way faster than something that has to remember the connectivity. Because it can also be massively parallelized. It doesn't have to have a cleanup phase. We could run this multi-threaded if we wanted to, right? We could go nuts. Although I don't think that actually matters because you just run multiple entities probably. So, whatever. But you get the idea. For the Lightboard, there are already large transparent TVs, so the only question is price and pen tracking. So, if you can make that, please make this. Please make a transparent TV with like a Wacom tablet digitizer. Like that. If you made that, you would sell thousands of those as well. Because every educator, if you can get that out before the pandemic ends, which honestly will probably be 5 years anyway. And plus there'll be another pandemic, right? There'll be another pandemic. And if you can get that out, because everyone needs to do this, right? So if you can make a transparent TV where you draw on the back of it with a pen, I mean, dude, that'd be so good. I don't have hardware skills, so I can't make that, I totally agree that if you can get a transparent TV, a large transparent TV, which LCDs should be able to do, right? Because an LCD is fundamentally transparent. So if you could just get a pen that was like built into that system, I mean, you maybe wouldn't even have to do that. You could even use like Lighthouse or something. You could use a VR kind of style tracking system if you wanted to. At that point, you wouldn't need the pen to actually be a digitizer pen like a Wacom tablet, because you could actually put, if you wanted to, you could just use Lighthouse or something, I suppose. Nairo2 says, at any point in your development as a programmer, have you ever dealt with pointer aversion? I tend to avoid storing pointers using array index lookups every time instead. To avoid the possibility of a bad null pointer, I feel like I'm limiting myself by doing this, but it also feels valid. Have you dealt with this and have any advice on it? Yes, I guess what I would say is, no, that's great. We do that in Handmade Hero all over the place, and it's probably the right way to program, right? Fundamentally speaking, the only benefit that a pointer provides is the ability to like relocate the memory around, so that it doesn't have to be like contiguous with something. I mean, because that's what an index. That's the problem you get with an index, is that it has to be quick to get the index translated to where the thing actually is. Now, if you don't have to do a lot of lookups, even that's not a problem, because just grab a hash table and you're done, right? Then it doesn't matter. But if you want really instant lookups like you get with a pointer, which is, basically instant, if you want instant lookups, then your indices need to be contiguous off a base, which adds some work for you, right? Thankfully, nowadays it's easier than ever, because you can do stuff like reserve 64 gigabytes for every array and just never commit them, and then they're all contiguous no matter how far they grow, right? So it's not that hard, actually. And so I don't know, maybe that's one solution, but it might limit your portability depending on what your targets are. But no, I mean, pointers are not good. Like, in general, pointers are pretty bad. They're too big, because usually you don't need 8 bytes to represent where something is. Usually, 16 bits, so 2 bytes or 4 bytes is plenty. And so it's pretty, you're bloating out the kind of cache footprint of everything you do by having these larger things. Pointers don't save. You can't save a pointer off to disk and assume it'll be valid when you load it back in, right? So you have this translation process to go to. Indexes don't have that problem. Indices just save just fine, right? It's harder to validate a pointer. An index is much easier to validate. You just say, look, is it less than 0 or higher than the total number of things I have? If it is, then it's invalid. A pointer, you get it and you're like, I don't know. I don't know if it's valid or not. Assuming that you're actually using the benefits of a pointer, which is that it could be placed anywhere and not inside a penned memory area. So I think you're right on target. I mean, I don't like using pointers for things that aren't pointers, like that aren't like I allocated a big chunk and I'm trying to say where it is. That's what a pointer does. That's what I use them for. So, most of the time in my code, when I'm using actual pointers a lot, it's stuff like the code you see on the screen where it came from an index originally, and I just turned it into a pointer to do a lot of stuff off of it, but I usually don't store that pointer. So, like, notice entities, they work with, like, IDs or something. We just don't use pointers as the primary thing a lot. So I don't think you want to use pointers anywhere where you didn't actually want a pointer, right? For permanent storage, for things that go into structs and stuff. For actual code, you use pointers all the time in the sense that you first, you load the ID's address and then you offset off the pointer. That's great. I mean, you can do that a bunch, like you see on the screen here. But yeah, for tracking things, I don't store pointers very often if I can avoid it. So I think you're right on target. I wouldn't change a thing. I guess the only thing I would add to what you had posted really is I think your emphasis on the bad null pointer thing. I don't think that's the interesting part, because I still like to have a 0 element for null anyway, right? Because I like to be able to know is something pointing to something or not, right? So I usually reserve index 0 for null. So it's not that I'm trying to avoid that in per se, although that it does give you new options. You can always have the null slot actually be there, so it actually does something, so that you don't have those problems. So there's all that. It's fine. But I love all the other benefits of indices. They're smaller. They can be saved to disk or transmitted over a network without translation. Like, IDs are great for a lot of reasons that don't have anything to do with null. So yes to the thing you said, but also add on all the other stuff. Is it possible to replace entire web stack by C? Well, I mean, no, because the front end has to be written in JavaScript, right? I mean, what you could do is you could write it in C and like compile it to JavaScript, right? But at the end of the day, the only safe way to ship things currently for the front end of a web stack is JavaScript. So when your 0 slot is reserved, do your loop start from 1 or 0 then? Your choice. Usually what I do is I let the 0 be valid, but just have all things in it that don't result in anything. So like if you're running a physics update or something, it has no collision volume and it has no velocity and no position and whatever. So it just ends up doing a 0 plus 0 equals 0 update on it, so that you could loop over it if you wanted to. But you don't have to. So you can just start everything from 1 if you want to, because you know the first one isn't valid. Or not valid, but isn't important. What would you say to the idea that pointers can be better because the compiler knows to prefetch the targets of pointers? This is not the case with indices, as there are no pointy semantics there the compiler understands. So, I guess, Stanislav, what compiler are you talking about, and which circumstance are you talking about where it enters prefetch instructions? Can you give me an example of some code that you think would have a compiler insert a prefetch instruction? Would be my first question. I have others. Like, if you actually want to talk about that part specifically, because we certainly can, but I would first need some code that you think, like, can you post a godbolt that shows a compiler generating a prefetch instruction of the kind you're talking about? And this will be the last question, because I'm gonna smoke some meats today. I'm gonna be doing some barbecue, and I'm getting hungry, so I want to go downstairs and start the smoke ore. Okay, well, I'll if I can remember Philadelphia, I'll post some pictures to hashtag food on the Molly Rocket Discord. Where did Stanislav go? Okay, here we go. I cannot give an example. It is just something that I've heard other people talk about when they give counterexamples for using these. Well, okay, well then we need to ask those people. I mean, first of all, does that even happen? Like, I don't compile with Clang a lot, but I can pretty much tell you that MSVC does not insert prefetch instructions. So I don't really know what that means. It doesn't sound logical to me, but so if we were to say that we were using like the most modern version of Clang, which does all kinds of ridiculous stuff in it, right? And I guess like we're like, you know, small structs, so it's really tiny, and the compiler would really want to issue a prefetch. Maybe, I don't know about it, but like, trying to think of what would convince a compiler if it was going to do something like that. I'm not optimistic. My first thought is that I don't think the people that are saying that probably know what they're talking about, but like, you know, just to be fair, let's not assume that. Actually, you know what? So let's see here. So we have a small struct, right, that just got like an integer in it. I don't know why this is returning. It's supposed to be returning an int. So we go through here. At each point through, I'm going to take this sum. Let me recall this sum. And I'm just going to add whatever the x is that's in the struct, right? And so we're just going to loop over to these and go. Oops. There we go. And we'll just see what we get here. I'm going to get rid of Osaka. So here's our asm, right? So, like, I don't even know what I would do to this code to get it to issue a prefetch. Because remember, in order to want to issue a prefetch, this thing's got to be tiny, right? We've got to be wanting to prefetch things that are pretty far out or something. I'm not sure. Like, without some idea of where the compiler would ever do this, I don't know. I've never heard of a compiler inserting a prefetch before that you didn't tell it to insert, right? But that doesn't mean it doesn't happen. So let me just try to answer the question this way. Since I don't know how to provoke a prefetch, I'll be honest with you, prefetching almost never helps. So, like, I don't even know if I can write a situation where I would prefetch, because it's pretty hard to find a situation where you want to do a manual prefetch. Once in a great while you do, but it's actually quite rare, right? But what I would say is, if we can find a situation in here where you actually have a thing where a compiler starts to prefetch, but an index would not have the compiler done it, I would want to see that and ask why. Because the compiler knows when it fetches from somewhere, whether it was fetching off an index or a pointer, right? I mean, so I really don't know. I mean, we could do something like, like a binary search or something. Uh, So, like we could do something where we were trying to go like, okay, if x is less than 0, go to the left. If x is greater than 0, go to the right. And sum all the way down, just so we have something to do, right? But again, I just don't know, like, I don't know how to make the thing do it. Let's suppose we said there was a ton of crap to do here, right? So now it knows it has tons of time to prefetch as well, right? I mean, maybe. I mean, it even auto vectorized this for us, right? Like, right? It even vectorized this, and it's still here. Check out that unroll. All right. If you say so, Clang. If you say so. But I'm not seeing any prefetches, right? So, Stanislav, my first thing to say was like, if someone says that, be like, show me the code you're actually talking about, right? Show me some code that actually generates this mythical prefetch, and then show me that the compiler stops generating the prefetch when you switch to an index. Because frankly, I don't see that would be the case. A compiler knows when you're accessing a memory location, and it knows that whether it's using an index or not, right? And so it's just not going to do prefetches. Oh, do you want to see an OS? There you go. Built-in prefetch is the way to hint. Okay, so built-in prefetch. Where do I put it? I guess I can look at that page. They're saying this is only GCC, so we're gonna have to switch. So do I tell you what to prefetch, though? But if I tell you what to prefetch, then this is a manual prefetch. So what? So that doesn't help, right? But that's me. I'm telling it what. So I could have put an index in here, right? So that's not. It's built-in prefetch location optional. But that's me telling it what to prefetch. So this is not. We could have just put an index in here. So that is not the compiler inserting a prefetch. That's me inserting a prefetch, right? So that's neither here nor there. If I'm inserting the prefetch, then I can just prefetch the indexed one just as easily as I can prefetch the pointer one, right? So that's not. That's just the same as me doing this, right? I would think. So that doesn't seem relevant to me. Yeah. So that's just a prefetch. That's a regular prefetch. And I could do that just fine. So we know that can't be it, right? GCC, I feel like GCC's code gen, I don't know, maybe I don't use it enough, but it seems better than Clang. Clang's code gen has just all gone to poop sauce. Clang just like poops out the crappiest code. I do not understand what is going on with Clang. I don't like it. It does really unpredictable stuff, and a lot of times it's just poop sauce. That's no good. I don't like Clang anymore. I just don't. I don't even know why it did this. Why did it unroll this? That just seems strictly worse. That just seems like increasing the code footprint, but without actually improving the performance. Like I do not know why that did that. I have no idea. I have no idea why this got unrolled. The vectorization makes perfect sense. The unroll makes no sense at all to me. Because basically, I mean, what's the benefit? There's no benefit to this unroll. I mean, look at this code, right? It's just mobs and pads. The test jump would be free. There'd be no cost to the test jump. And it's always 256. It's a constant. So it's a perfectly predicted jump. Never mispredicts, right? So literally all this did, I don't know, like, I'm not a performance guy. So, like, please, someone out there, correct me if I'm wrong. But all this did was just blow out the cache. It just blew out the iCache for 0 performance gain. Right? Like, this will run at like the exact same speed as the one with the jump in it, right? So I don't know. I mean, yeah, you can go test it. I mean, go ahead and run them both versions, but it should be. This should run. It's not just that it should run the same. It's literally going to do this. This is what the CPU would already have done in the other case, because test jump doesn't exist. Like, the front end just appends the instructions, right? So this is actually what the CPU would actually just do if you had just written the test jump, right? So like, unrolling it maybe so that there's 2 per loop might have been necessary. I don't remember, but that should be it. Like, at most you should have enrolled it one time, but possibly just not at all. Maybe I'm wrong. Let's see. So let's look at GCC. Looked sane. Let's see what it produced and see if I can see why something wrong with it. That is why you should have unrolled. You know what I'm saying? So, whoa, okay. So 1024, so that's the jump. So I'll be honest, I'm not sure I totally follow that. That does look weirder to me. Good old MSVC, no auto vectorization. I support that. I'm totally fine with that, by the way. So GCC's code is still a little weird. It's not what I would have expected. So maybe that's also not what I want. But this looked pretty good. I mean, yeah. I guess this is not quite right because you don't really need to do that, but like it's much closer. Is there anybody here who generates the loop that I'm thinking of? I mean, that's pretty good. Actually. So this is what I would have expected. It's still a little more than I don't think it's I think it's still too large. But that's much better, right? And so what I'm trying to say is like, so look at this code. So this, and this. Those are one fused issue. This is one. They are both going to execute during this. Like all of this stuff is on different ports than these, right? So these will just issue right at overlapped with this, so they're free. So once you get to that point, why keep unrolling? And this is why I say it seems still a little too much, because I feel like you could have just stopped here. I don't think you needed the second one, because this is already, once you've done this where you loaded all of these, you can just do this and be done, right? So you add 16 here instead of 32, and off you go. Try OZ in Clang? No. I want it to vectorize. That's the right code. It should only be it's unrolled it like one more time than it should have. But it's still fine. This code is fine. Like that code is fine. This code is like not fine at all. Like that, I'm pretty sure if you went and asked a person who really was good at optimization, they would say this was very bad. Like you should not have done that. Because this code runs the same speed, or should run the same speed. This code should run exactly the same speed, but it's much more efficient in the cache. So over the long run, it will be faster. So I don't know. Even so, I think it went to one too many. I don't think this should be here. Actually, I should say I don't think this should be here, right? I gotta go. I'm gonna go make some tasty barbecue. So I'm gonna wrap it up for today. We're gonna look at the collision detector when we come back next time, and we're gotta make that not be bad. So that's our goal. Alrighty, let's see here. I didn't even have Handmade Hero up. My bad. Thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow the series at home, you can always pre-order the game on handmadehero.org, and it comes with source code. You could go write the collision detector that I was just hypothesizing and tell me if it's any good. That way next week I can just find out from you folks whether it worked. That's it for today. I'll be back here next week to play around with that and see what we actually want to do. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.